Hello friends, very good morning. Myself Dr. WFhMaJks, and in today's video we are going to learn the development of a cone which is cut by two section planes, and both the section planes are normal to VP. One of them is inclined to HP while the other is perpendicular to both HP and VP. Since the section planes are perpendicular to VP, they are seen as lines in the front view. So this concept you have to remember. Now let's see what is the question we have for today's video. A cone diameter of base 50 mm and axis 70 mm long, resting on its base on HP, is cut by two section planes. So first of all, you know very well, whenever a cone is resting on HP, the front view is going to be a triangle and top view a circle. So let us first of all write down the top view, a circle of diameter 50 mm, and front view, a triangle with height is equal to 70 mm and base is equal to 50 mm. That is equal to the diameter of the circle. And friends, it is cut by two section planes as I told you. One of them, both of them being perpendicular to VP, draw the development of the lateral surface of the cone. The inclined section plane passes through the left end of the base, and both of these intersect on the axis. Friends, let us take the section plane S1, S1. This is at an angle of 30 degrees to the horizontal, again perpendicular to VP, and hence it is seen as a line here. I call this section plane as S1 and S1. On the same line, the other section plane is perpendicular to both HP and VP, and hence it is seen as a line in the front view and also as a line in the top view. So friends, to start with, let us complete the marking of this base as A, B, this is C, this is E, this is C, D, E, F, this is G. So we'll mark this as A dash, this is E dash, and we got C dash and G dash in between. C, G dashes are there. And now friends, after marking the section plane, which intersect at this point somewhere along the axis O dash, O1 dash. And now friend, let's see how to obtain the true length of it, because you know very well, for all the developments of the cones, we make use of the true length or the actual length. And here, after construction of this figure, friends, you can obtain what is called true length of the generator, which I call it as R. R is the true length of the generator, that is O dash E dash. And this can be obtained only after completing the front view of the solid. So friends, I will mark here O, the apex of the solid. And now friends, to obtain the development of this part, that is the lateral surface, we will have to obtain the true length, and that true length I have marked here as R. This total length is R. And before marking this, we need to calculate what is called theta. Theta is called the sector angle and is given by the formula theta is equal to R by R into 360 degree. This you should remember. R is the radius of the base. Diameter is 50, radius is 25. And this R is obtained after the construction of the figure. You can just keep a scale and obtain the length into 360. So you are going to get a numerical value, some angle 140, 150, something like that. So that angle is marked here. So we draw a vertical line, mark this angle theta, and this sector is to be divided into the same number of parts as that of the base of the solid. The base of the solid is a circle which is divided into 8 equal parts. So also this has to be divided into 8 equal parts. So what do we do next, friends? Let us start with the development of the portion of the solid which is cut by section plane S1, S1. It is at an angle of 30 degree as I told before. And here you should remember the last generator O dash A dash is completely removed after it is being cut. And hence, you have to start the development only from A. So A, B, C, D, E, F, G, H, and again E. This is how you mark, because this is totally removed and we have to mark this way. Next, friends, let us see where all we get the points. Friends, the section plane S1 is passing through A. So A is going to be one of the points. Yes, I have marked a point and A. Then OB and OH, this is H, this is B. So OB and OH fall on the same line and these two are cut here. But this is not the true line. Shift that or move that to the end point. Take that measurement on OB and OH. So I will move it up. This is for OB, this is for OH. These two distances are the same. So I will say OB and OH. And friends, on the same line, the generators OC and OG are cut here. OC and OG are not the true length. You can shift that to the true length generator, that is the last line, and take that measurement, this much distance on OC and OG. So I will move it up, OC and OG, I will mark the distances. Next, friends, after this, let us see what is left over. Now, this section plane, this is the vertical section plane, is also cutting this OS and OG. And before that, let me mark this. This point is D and F. So D and F are cut here. Sorry, this is not section plane. So here on OA is marked at this. OB and OC and OG I have marked, and OC and OG marked. OC, this is OB, OH I have marked. Next, friends, you have this vertical section plane which is passing through O. So O is going to be one of the points. And then these two are intersecting at the midpoint of the axis, that is on OC and OG, that I have marked, friends. Now, friends, we can see here that OE is completely to be retained, OE is retained, and here we have got OD and OF, they are also not touched by the section plane, that is OD and OF. OD and OF are to be retained, and then you have got OC and OG are cut up to here, OC and OG are cut here. Then these lines like these two we have marked, and this is cutting up to the center. So friends, we have to join all these points so obtained by a smooth continuous curve, and this part is to be retained. So friends, what I do, you can observe a very important thing here, that this portion is going to be a straight line in the development, whereas this is going to be a curve. So friends, I am going to join these 3 points by a smooth curve, and the same lines here also I join by a smooth curve, but on OC or OG, this part is going to be a straight line. Hence, I am showing by a straight line here. So this is a very interesting problem. So this portion up to here, it is a straight line. On the same lines, here also we have got this OD, OE and OF. Yeah, OD, OE and OF are to be retained. And this is going to be a straight line again. Friends, I will join this by a straight line. Friends, what is the portion that is left over here is this complete base is retained. So I am going to show that this complete portion of the sector is retained. And friends, this is how we obtain the development of the lateral surface of this. And remember the figure you got here, from here to here, this arc, then the sector, arc again, and this is the lines retained. And friends, what are the lines that have to be retained here? OE, OD, OF. Yes, OE, OD, OF are retained, and this will give you the complete projection of the lateral surface. That is the development of P. Development of P. P is this part which is shown in color here. I will mark it as P. Friends, you can see even though it is a cone, you have some part with straight lines. That is, this part is straight line, whereas the bottom is completely retained. I have shown by a visible line. Vertex is included, so I have drawn it completely. Friends, I hope the presentation was interesting. Please go through the complete video, and if you like this video, do share with all your friends without fail. And I observe that there are many viewers who are watching this channel and they have not subscribed to my channel so far. So I request all such channel viewers to subscribe to my channel and then watch it. Thank you, friends. Have a wonderful day. I thank you very much for watching my YouTube video.